Good morning, students. This is Latif sir. In this video, I will continue the chapter 1 of class 9 chemistry. The topic is language of chemistry. Today, I will discuss about valency. So, what is valency? You have already studied in lower classes that valency is the combining capacity of an atom or of a radical. But the modern definition of valency is the number of electrons that an atom can lose, gain, or share during a chemical reaction. It's called its valency. This is the modern definition of valency. According to modern definition, the valency is equal to number of electrons that an atom can lose or gain or share during a chemical reaction. Okay. Now see, if first it is given cation and anion, these all you have already studied in class 8, that cations are formed by losing electrons and anions are formed by gaining electrons, and cations are positively charged ions. When an atom loses one electron, then it will form monopositive cation, okay, or unipositive cation. Similarly, if it loses two electrons, then it will form dipositive cation. Similarly, if an atom of an element accept one or more electron, then it will form anions, and anions are negatively charged. Generally, metals they form cation. And by losing one or two or three electrons from their outermost shell. And non-metals like oxygen, fluorine, chlorine, and fluorine, chlorine, sulfur. These non-metals generally form anions by losing one or they form anion by gaining one or more electrons. Okay, so cations are positively charged ion and anions are negatively charged ion. And how valence is related to the number of electrons in the valence shell. Okay, suppose if there are 1, 2, 3 or 4 valence electron in the outermost shell of an atom of an element, then the valence will be equal to the number of electron in the valence shell. If again I am saying, if the number of electrons in the valence shell is less than 4 or equal to 4, then valency is equal to number of electron in the valence shell. But if the number of electrons in the valence shell are greater than 4, that is 5 electrons or 6 electrons or 7 electrons, okay, or 8 electrons in the valence shell, then valency is equal to 8 minus number of electrons in the valence shell. Okay, so if 1 electrons, 2 electrons, 3 electrons or 4 electrons are present in the valence shell, in the outermost shell of an atom, then valency will be 1, 2, 3 or 4 respectively. And if 5 electrons are there, then valency will be 8 minus 5, that is 3. If 6 electrons are there in the valence shell, then the valency will be 8 minus 6, that is 2. If 7 electrons are there in the outermost shell of an atom, then valency will be 8 minus 7, that is 1. And if 8 electrons are there in the outermost shell of an atom, then valency will be 8 minus 8, that is 0. Okay, so remember this table. Now see, the valency of an element or of a radical is the number of hydrogen atoms that will combine with or displace one atom of that element or radical. This is one more definition of valency. According to this definition, the valency of an element or of a radical is the number of hydrogen atoms that will combine with or displace one atom of that element or radical. For example, in in hydrogen chloride HCl,
chlorine atom is directly attached with one hydrogen atom. So valency of chlorine is 1 because it attached with one, it combined with one hydrogen atom. Okay, similarly in water, the oxygen atom combines with two hydrogen atoms. So in water, the valency of oxygen is 2. Similarly in ammonia means NH3. In ammonia, nitrogen is combines with 3 hydrogen atoms. So valency of nitrogen is 3. Okay. Similarly in methane, the carbon atom, the central carbon atom combines with 4 hydrogen atoms. So valency of carbon atom in methane is 4. So valency is also related to the number of hydrogen atoms directly attached with the directly attached to the element. Okay. Now see, next term is variable valency. This is very important term, variable valency. Okay, so what is variable valency? Certain elements can exhibit more than one valency. That is, they can show variable valency. For example, iron. Iron can show two type of valency. One is 2, another is 3. Because iron can show two type of valency. One is 2, another is 3. Okay. So the lower valency, for the lower valency you have to use the suffix as. That's why Fe2 plus is known as ferrous and Fe3 plus is known as ferric. In Fe3 the valency of iron is 3 and in Fe2 plus the valency of iron is 2. Okay, so certain element can exhibit certain element like iron, copper, tin. These elements can exhibit more than one valency and this is known as variable valency. Okay, and the reasons for variable valency: certain elements can lose electrons from their outermost shell. At the same time, they can also lose electrons from their inner, that is inner shell or penultimate shell also. Okay, that's why they can show more than one type valency. So an atom of an element can sometimes lose more electrons than are present in its valence shell. That is, there is a loss of electron from the penultimate shell too. Okay, therefore such an element is said to exhibit variable valency. So variable valency, example of variable elements which can show variable valency are iron, copper, tin, and some non-metals also can show variable valency like nitrogen, phosphorus. Okay, this element nitrogen, phosphorus, sulfur, this element can show variable valency. These non-metals, certain non-metals can show variable valency such as nitrogen, phosphorus, sulfur. Okay. And nomenclature of elements which can show variable valency, you have to use, if an element exhibit two defined positive valency, you have to use suffix as. For the lower valency, I have already told, and suffix ik for the higher valency. Okay, and modern chemists use Roman numeral in place of this trivial name. For example, for essential 2, in essential 2, tin, Sn means tin. In essential 2, tin is present as Sn2 plus, and in essential 4, tin is present as Sn4 plus. Okay, so in essential 2, tin is present as Sn2 plus, so it is stannous chloride. Okay, which is written as tin 2 chloride, and in essential 4, tin is present in plus 4 charge. So the valency of tin in essential 4 is 4, so it is stannic chloride, which is written as tin 4 chloride. An example of nonmetals which can show variable valencies like nitrogen, phosphorus. Nitrogen and phosphorus exhibits valencies of 3 and 5, while sulfur can exhibit 2, 4 and 6 3 valencies. Okay. And here in this table, element examples of variable valency. Okay. See this table. In this table, example of variable valency given. Iron can show two type of valency, ferric and ferrous. Okay, ferrous means Fe2, that is iron. FeO, in FeO iron is present as Fe2 plus, so it is ferrous oxide or iron 2 oxide. And in Fe2O3 iron is present as Fe3 plus, so the name of this compound is iron 3 oxide. Similarly, copper can show two type of variable valency. One is copper 1 and another is copper 2, that is Cu plus 1 and Cu2 plus. And Cu plus 1 is known as cuprous and Cu2 plus is known as cupric. Similarly, mercury can show two type of valency, 1 and 2, and Hg plus is known as mercurous and Hg2 plus is known as mercuric. Similarly, lead can show two type of valency, one is 2 and another is 4. And lead means Pb, so Pb2 plus is known as plumbous and Pb4 plus is known as plumbic. And tin can show two valency, one is Sn2 plus, another is Sn4 plus, so valency are 2 and 4 for tin means Sn, so Sn2 plus is known as stannous and Sn4 plus is known as stannic. Okay, now see radicals also you have already studied in class 8, class 7, 8. Radicals are atoms or group of atoms. Radicals are atoms or group of atoms of the same or of different element that behave as a single unit with a positive or negative charge. Radical is an atom or group of atoms of the same or different of different elements that behave as a single unit with a positive or negative charge. Okay, a radical is called simple radical when it is an atom, an atom only, like Na plus, Mg2 plus. This ion also simple radical. Okay, and a radical is called compound radical when it is made up of group of two or more different atoms, which is also known as polyatomic radical. In class 8 you have already studied about polyatomic ions, and polyatomic ions are polyatomic radical. For example, SO4 2 minus. Okay, so SO4 2 minus is a polyatomic radical. PO4 3 minus is a polyatomic phosphate radical. Okay, and the positively charged radicals are also known as basic radical, and negatively charged radicals are known as acid radical. Remember this one. Positively charged radicals, that is cations, are also known as cations means positively charged radicals, they are also known as basic radical, and anions are also known as acidic radical. So there are two types of radical, one is acid radical, another is basic radical. So first see this table. In this table 1.3, list of some common electrovalent positive ion. That means in this table some common example of some common basic radicals are given. You have to read this table properly, very important table. Okay, so basic radicals, I have already told, basic radical are also called electrovalent positive ions, that is they are cations, and there are many types: monovalent basic radical or monovalent electropositive radical, divalent electropositive radical, trivalent electropositive radical, and tetravalent electropositive radical. Example of each type of radical you have to remember. First, monovalent basic radical or monovalent electropositive radical. Example of such monovalent electropositive radicals are ammonium, that is NH4 plus. Their name and their formulas, both you have to remember. Very important table. Otherwise, you will not able to write down the chemical formula of the compound. Okay, so monovalent electropositive radical are NH4 plus, that is ammonium, auras, that is Au plus, argentas, that is Ag plus, okay, H plus, that is hydrogen, potassium K plus, and sodium Na plus. These are some example of monovalent electropositive radical. Divalent electro example of divalent electropositive radicals are argentic, that is Ag2 plus, barium, that is Ba2 plus, calcium, that is Ca2 plus, nickel, that is Ni2 plus, mercuric, that is Hg2 plus, magnesium, that is Mg2 plus, uh, platinum means Pt2 plus, zinc Zn2 plus. So all these examples you have to remember. Example of divalent electropositive element. Now see example of trivalent electropositive element. Trivalent means valency is 3, divalent means valency 2. Okay, that is 2 plus. Divalent means 2 plus, and trivalent means 3 plus, and monovalent means 1 plus, you will see. So trivalent electropositive radicals are aluminium 3 plus, Al3 plus, aluminium, arsenic, that is As3 plus, bismuth, Bi3 plus, chromium, Cr3 plus, Fe, ferric, that is Fe3 plus. These are trivalent electropositive radical, that is trivalent basic radical. And last one is tetravalent basic radical. Plumbic, that is Pb4 plus, is plumbic, is tetravalent basic radical. Platinic, that is Pt4 plus, stannic, Sn4 plus. These are tetravalent basic radical. And now see table number 1.4, list of some common electronegative, that is acid radical, anions, acid radicals. Acid radicals are also monovalent acid radical, divalent acid radical, tetravalent acid radical, and trivalent and tetravalent acid radical. Example of each type of radical you have to remember. So first see monovalent acid radical. As example are acetate, that is CH3CO minus, hydrogen carbonate or bicarbonate HCO3 minus, bisulfide HS minus, bisulfate HSO4 minus. All these example you have to remember. These are all monovalent. And divalent acid radicals examples are carbonate CO3 2 minus, dichromate Cr2O7 2 minus, oxide O2 minus, okay, sulfate SO4 2 minus, zincate ZnO2 ZnO2 2 minus, plumbite is PbO2 2 minus. And tetravalent acid radicals are arsenate, that is AsO4 3 minus, nitrite N3 minus, aluminate AlO3 minus, okay, arsenite AsO3 3 minus. So there's a trivalent electronegative or trivalent acid radical. And last one is tetravalent electronegative or tetravalent acid radical. Examples are carbide C4 minus, ferrocyanide FeCN whole 6 minus. Okay, so both table and the formula of all the acid radical and basic radical which are given in both table, you have to remember. Very important. Otherwise you will not able to write down the chemical formula of unknown compound. Okay, because this basic radical and acid radical combine to give the to form compound. Okay, so how to write the formula, chemical formula for compound? You know, compounds are formed by combination of this acid radical and basic radical. And writing chemical formula, the simple method, writing chemical, how to write the chemical formula of a compound, the name of the method is crisscross method. So next topic is writing chemical formula. Again I am saying example of all type of acid radical and basic radical you have to remember. Okay, otherwise you will not able to write the chemical formula of the compound. So these two table are very important. Okay, all radical you have to remember. So then write how to write chemical formula of a compound or molecular formula of a compound. This is Kirchhoff's method, and this topic was given in class 8 syllabus to some extent. Okay, so during writing chemical formula of a compound, you have to follow some rules. First, you have to write the symbol of basic radical, then symbol of acid radical. Okay, first you have to write the symbol of basic radical and then symbol of acid radical. Then you have to write the valency of each atom on the top of the symbol. Then divide the valency number by their highest common factor. If there is any common factor, then divide the valency factor by their highest common factor to get the simple ratio. Okay, and ignore the plus minus symbol of the radicals and interchange the valencies of the radicals. And next step is the step 4, write the interchanged valency number to the lower right of the radical. And if the radical is a group of atoms and has a valency number more than 1, enclosed within a bracket. Okay, example is given. First one is writing chemical formula of magnesium chloride MgCl2. So magnesium means Mg2 plus and chloride means Cl minus. You know that. First you have to write the symbol of cation, that is basic radical, then anion. So it is written Mg2 plus and Cl minus. Now write their valency at the top. So Mg2 plus, valency of Mg is 2 and valency of chlorine is 1. After that you have to exchange their valency and you have to write as a subscript. Okay, so valency of magnesium is exchanged with chlorine and valency of chlorine is exchanged with magnesium. Now join them and you will get MgCl2. Very simple method. Second one is calcium oxide. You can see in calcium oxide, calcium and oxygen are present. Calcium has symbol Ca2 plus and oxide means O2 minus. See that valency of both calcium 2 plus and O2 minus is same. So there is a highest common factor which is 2. So divide the valency of both calcium and oxygen by 2 because the common factor of 2 and 2 is 2. So after dividing by the common factor, you will get this formula CaO. Okay, and for chemical formula of aluminium oxide, aluminium hydroxide. Aluminium means Al3 plus and hydroxide means OH minus. OH is a polyatomic ion, that's why it bracket is given. So aluminium 3 plus and OH minus. Now exchange their valency. So after exchanging, it will be Al1 and OH whole thrice. So the formula of aluminium hydroxide will be AlOH whole thrice. Okay, sodium meta aluminate. Sodium means Na plus and meta aluminate means AlO2 minus. First you have to write the formula of a symbol of cations, that is Na plus, and then anions, that is aluminate, meta aluminate, AlO2 minus. Now see, in both cases the valence is 1, so the formula you can directly join them and the formula of the sodium meta aluminate will be NaAlO2. And sodium, next one, sodium aluminate, Na plus AlO3 3 minus. Sodium means Na plus and and aluminate means AlO3 3 minus. Aluminate means AlO3 3 minus. So sodium, after exchanging their valency, you will get this one Na3 and AlO3 whole 1. Okay, so the formula of sodium metaaluminate will be Na3AlO3. Okay, so and here one box is given, you can see. Important formulas. This table is also important. Many compounds, chemical formula of many compounds are given. For example, formula of potassium chloride is KCl. Formula of potassium chloride is KCl. Formula of potassium plumbite is K2PbO2. Okay, K2PbO2. Formula of sodium hydrogen sulfide is NaHSO4 SO3. You can derive this formula using the following rules. Okay, very simple. uh, Formula of, suppose formula of potassium zincate, then K2ZnO2. This formula and the name both you have to remember. Formula of ammonium sulfate is NH4 whole twice SO4. Okay, so this both table also important, because in exam you will asked this type of question, that is write the chemical name of the following compounds, chemical formula of the following compounds. So before writing the chemical formula, or how to write chemical formula of a compound, first you have to know the symbol of different radicals, that is acid radical, basic radical. Okay, and using the symbol of different radical and using the following rules, you can derive the chemical formula of a compound. Okay, and all this formula of all this compound you have to practice well. Okay, so both the table is important, very important, this table, writing chemical formula. And in next class I'll discuss about naming certain compounds. Okay, thank you students.